Welcome to Embedded FM. I'm Alicia White alongside Christopher White. We've been talking about learning to program for embedded systems, generally in C. Last week I mentioned that Chris Gamble has added some software to his Contextual Electronics Apprenticeship program. He did that by convincing a pair of embedded software experts to do the lectures. This week we're going to talk to one of those experts, Eric Hankinson. Before we get started, Christopher and I were on the AMP Hour last week. Speaking of Chris Gamble, we were filling in for Dave Jones. Things went well. There were some familiar voices from this show's past and plenty of giggling, as you might expect. It is show number 281, Crossovers and Call-ins.
Hi, Eric. Thanks for being on the show today.
Hey, guys. Thanks for having me on.
Could you tell us about yourself?
Sure. So I am primarily a software developer. I've been in the industry for about 17, 18 years or so. And probably about the last year and a half or 2 years, I've been getting more into embedded. But enjoy doing a lot of different things. So outside of even tech, so that I think really kind of helps for bringing some different aspects to what we're doing. So I do a lot of web and mobile development as well. So lots of different languages and platforms and DevOps and all that good stuff.
Cool. Well, let's go on to the lightning round before we get into digging in more on that.
Certainly.
So, favorite programming language?
Oh, Python.
What programming language should high school students learn?
Python.
I or Kyle.
Ooh. Neither. I have to pick one, don't I?
You must pick.
Oh, God. I guess Kyle. I don't know. Lesser of two evils. I don't
it's
like
a devil's
either answer.
choice.
It is. I don't like that.
Have you seen the new Star Wars movie?
Yes, I have. Very, very pleased with it, to put it bluntly.
BB-8 or Chewie?
BB-8.
Yeah,
I like robots.
It's tough.
Wow.
Yeah.
Favorite processor of all time?
Oh. Wow, there's a question. So I guess it would be, I'm gonna go back to the because I can't. Wow, for the life of me, I can't think of the processor. But I really got my start with the Commodore 64. So
I think that was a 6502, wasn't it?
Was it a 6502? Yeah, I couldn't remember what it was. That was like my start.
Yeah,
yeah.
Great.
I think that's that's like the old school, and everybody's got an emulator for it now and everything. But I kind of soft spot in my heart for that. So
I have to look it up now. So don't have people emailing us.
I know.
Hardware or software?
Software.
Same true for work versus home?
Yeah. Well, work I would say is probably primarily software, and you probably hardware for home. Because I don't know, that's a tough thing because it's I like both. I enjoy doing both, and then I am also looking into doing things like just making up signage and doing stuff like that, where I'm taking when I combine hardware and a little bit of software if there's a microcontroller involved, but also things like woodworking or machining or other things to actually
That's
make.
more than one word.
That is not very light.
Physical signage. Oh, I know. I know. I'm breaking the rules here. So sorry, guys.
Let's see. I don't know if we've done this one. Favorite drink at 4 p.m. Coffee, Mountain Dew, or champagne?
Oh, yeah. You guys didn't include beer.
I thought
you were supposed to include
beer.
that. Good. We're gonna add a beer. Yeah.
8-bit or 32-bit?
32-bit.
Little or big Indian?
Oh, does it matter?
Yes.
I have to pick one.
No, that was my answer too.
I know. I'm sorry. I'm like, I agree with that answer. I guess big Indian.
Correct answer.
Object-oriented or procedural?
Or functional. Yeah, object-oriented primarily.
Well, you added functional, so now you're going to have to explain what all three are.
Right. Well, so there's a little bit. So I've been basically practice a little bit in the last week being away at a conference, regional conference in the area, and a lot of focus was on functional programming and functional languages, right? So Erlang, Haskell, Clojure, all that stuff. So I've been basically spent a little bit of time dabbling in Erlang, and it's cool. I'm still having a hard time kind of wrapping my head around that, but certainly I think that's getting more prevalent. So I found that question interesting. So, but for the most part, my head's still very firmly in object oriented. So
cool.
One more question.
Okay. One more lightning round question.
All right.
Answer.
Do you work on a boat?
Yes, I do. My full-time job. We'll say yes, and then you guys can ask me to explain. How's that?
Okay, before we go on back to the Commodore 64, it was a 6510, which is very closely related to the 6502, but nice. It had some extra junk.
Extra junk.
So we'll call it a 6502.
All right.
With extra junk.
Plus junk, yeah.
Okay, so I introduced you talking about contextual electronics.
Yes.
And we heard about that from Chris Gamble like 2 years ago. He started it.
Yes.
But it's changed some. So tell me, as though I've never heard of it, what is contextual electronics?
Sure. So contextual electronics at its core is effectively an online apprenticeship for learning electronics. So right now we have two major projects. One is the Bench Buddy, which is all purely analog. So you learn a lot about analog electronics, and your first foray, if you've never done it before, into laying out a PCB and actually designing a lot of the parts. Probably don't have their pad representations and whatnot in KiCad, which is the EDA or PCB layout tool that we use in the course. And then the newer project is called Roll With It, and that is a telepresence robot. And that actually is a mixture of both analog and digital electronics with multiple microcontrollers. The current microcontroller, I recall we're going with is a STM32F03, I think it's an 031, and it's a Cortex M0 class processor. So where a lot of the initial videos that we have up right now in the coursework are based off of a Nucleo dev board that has an F030 R8 processor on it, which I think is like 64K, and it's 2 I2C buses and some other stuff that's on it. But we're using that board to kind of get people jump started in the course as we build one of the primary boards called Central Command that actually will have the initial microcontroller on it, and then program it from there. So
I understand the electronics part, but your background software.
Correct.
And so you're teaching software to electronics people?
Yes. So myself and my counterpart, Ron, we are teaching the members of contextual electronics, whether they have an EE background or not, or potentially even if they have a software background or not, how to program embedded devices, specifically these Cortex processors using C, and open source tooling like Eclipse and OpenOCD and whatnot.
And so half of teaching people embedded software things like working with a Nucleo, I don't know how to say that. Whatever, yeah. That little board you mentioned.
Yes.
Is dealing with everybody's OSs and their available tools. I mean, when I helped out at the SparkFun thing tutorial at SuperCon, that was 90% of what we did. How do you get around everybody's particular setup?
Yeah, so that is a lot of this whole idea of what was done for contextual electronics is really based off of my used to be a systems administrator in another life, and a lot of what I did was try to make my job easier, because not unlike programmers, sysadmin folks like to be lazy too. And so if there's things that they can automate, they will. And so I actually used a open source tool called Vagrant. It's created and maintained by a company called HashiCorp. And Vagrant is a way to basically script the creation of virtual machines. And so in this case, there is a Vagrant file, which is exactly what it's named. And that's basically a setup script. And that then relies on a handful of bash scripts that I wrote that do a lot of work of installing packages and running sed and awk and other tools to basically modify configs and whatnot. And what happens is that you use Vagrant and VirtualBox, you install those tools. You run a command called Vagrant up in the project directory after you download it off of the Git repository. And what it will do is it will completely script the creation of this virtual machine, which I think is still Ubuntu 14.04 LTS server. And it'll put a user interface and everything in it, specifically, and then basically pull out all the parts we don't need necessarily. And by the end of that operation, which is depending on your internet speed, an hour, hour and a half, or potentially faster, you actually have a pre-baked environment that has Eclipse. It has the GNU ARM Eclipse plugin. It has OpenOCD installed and a command line tool called ST-Link. It'll have KiCad installed. It'll have the Atom text editor that GitHub created. And even a couple rules on VirtualBox that anytime you plug in the Nucleo board, it'll actually sense the ST-Link programmer and automatically associate it with the virtual machine itself as soon as you plug it into the system. So you shouldn't even be prompted by your host OS like, hey, do you want to use it, in Mac or VirtualBox, or do you want to use it in Windows or VirtualBox? That takes care of it for you. So what that allowed us to do is get a heterogeneous environment for everyone. So it doesn't matter if you're using Linux or Windows or Mac, you have the same environment across the board. And that really simplifies the job of Ron and myself with trying to help individuals in case there happens to be, some sort of a problem with the development environment.
I know my Chris is very into virtual machines, and I have only used them occasionally and have not had a lot of luck with them.
It's the only way to fly.
Yes, anymore. I mean, even, I primarily at Lean Dog, my full-time job, we're all completely Mac. So anytime I need to do anything Windows, if I'm working in a project in .NET or, for example, I have to use TI's Code Composer Studio, pretty much I have to be in Windows. So virtual machines have really made that a whole lot simpler to do.
So who's your target audience for your part of contextual electronics? Is it just for electrical engineers or people who want to go into EE?
Well, I don't think so. I think it's really anybody. I think it's anybody that's willing to learn embedded programming. So I don't have a firm grasp of what everyone's background is as far as the current members, but the couple people I've talked to, some of them are, hey, I do Java programming and some other thing, for my full-time job. And so I'm learning electrical engineering and I'm learning C and I'm learning, how to, quote unquote, properly build embedded software or firmware for microcontrollers. And so I think you just kind of, the students are kind of from all different backgrounds and skill levels, which is cool because then that really helps, kind of guide us with what are people concerned with or what are they having problems with? And then I think that gives us a better idea of where folks are coming from when we give and create future videos. So,
how important is the community to everything? I mean, I saw that you answer a lot of questions on the forums and whatnot.
Yeah. But
how much back and forth is there? Do you have office hours?
I was about to ask.
Not necessarily, right? Nothing certainly fixed. I think there is an option actually with contextual electronics. You can actually set up time with one of us individually if you wanted to have some like additional one-on-one I guess tutoring would be a good word, or mentoring, maybe actually even better. But primarily, it's just kind of whatever the off time is. And so because Chris and I are not in different time zones. We're very close to each other, physically located. But for like, say, Ron and myself, it actually is kind of helpful because depending upon what's going on, if it's, late at night, I might not see the questions and he will technically see it, his early morning. So we kind of have each other covered. If there's, different members in different locations and time zones and so on to, kind of answer questions in a, fairly expedient manner, right? Because that's one thing we're certainly if you're asking a question, you're trying to do stuff, you don't want to rack your brain and then kind of wait, anywhere from 48 to 72 hours for a response, sort of thing, right? So we try to be really good about that. In my case, I have very small kids, so really nothing happens until pretty much everyone's in bed, and then I have time to go out and help other individuals or create content or what have you.
So you mentioned different levels. We should probably, when Chris was on before, you paid for the entire module, and it's a lot different now. It's month to month.
Yes.
And you can audit it for $30 or participate for $60, or the whole tutoring and hand-holding is $279, and that's all you can consume for a month. Well, I don't think you get all the tutoring you can consume for a month. I think that's limited to a couple of hours, but you can get all
just leave the
videos.
Open.
Yeah, it's definitely not all you can learn as far as the tutoring is concerned, right? So it's very much like I think the Genius Bar at the Apple stores do this. It used to be like, hey, just come in anytime, do whatever. No, oh boy. And now I haven't, I know Ron has helped one of the members. I have not yet. So can't remember what kind of the time breakdown is, but there is, you get a chunk of time with that $279 price. So I think a lot of people are participate, if I recall, as far as like kind of the breakdown of, where folks are at.
For $30 a month, you get access to all the videos. For $60, you get all the videos and the forums.
Yes. And then there is even, I think, a handful of videos. If you're kind of like following along, there's actually a handful of videos that participate members get that are kind of like, hey, we're going to, go and try to do this thing on your own. And then we'll circle back and kind of, you can see how Ron or I would do it. Sort of thing, and it kind of gives the opportunity for members to I don't know, for lack of a better term, compare notes, right, to what's going on and how they're approaching it versus how we're approaching the problem.
And that failure part is sort of, or not failure, the try it yourself and maybe fail method really allows a lot more learning.
Yes, I agree. I think that actually really reinforces it, right? Because I think as an individual trying to learn something, you definitely get more out of it. So there's a handful of videos where, even though I went through and I basically wrote something in beforehand to make sure like, okay, this actually works, the way I think it should. There's certainly been times where I'm actually recording the video, I'm going through and I'm showing the members how to do something. And then something falls over, usually OpenOCD, which I'm sure you guys have encountered. But it's just like little quirky things where it's like, oh, that's weird. Like, why did that not work? Or I think it was the recent Intro to I2C video where I go ahead, we build a firmware, everything builds is according to the compiler. And then we go ahead and we fire it up, and OpenOCD is like, "Oh yeah, no, we're great." We go ahead and we'll start get past that initial breakpoint, and appears everything's running on the micro. And then I go to take readings with the Saleae logic analyzer, and it's nothing. I get nothing, and it's like, wow, that's really weird because I'm pretty certain the code I wrote works, and this should all be fine. So hey, let's go and figure out like why this didn't work, and kind of review the code. No, looks like all of our settings are correct, and everything seems to be fine in the logic analyzer, and then redeploy, and all of a sudden, everything's fine, right? Or some other little quirky thing like that.
It's good for them to experience that.
The have you turned it off and back on again is an important part of learning when you're dealing with technology.
Yes.
Well,
right?
I can imagine people coming in, with some background in programming from, college or whatever, or doing some basic programming or some Python or JavaScript or whatever, where everything just always works, right? I mean, assuming you write the code correctly, there's no weird things that happen. And so everything seems deterministic. But once you get all these parts together that are coming from third parties and hardware, everything's out the window. And it's probably a good learning experience to see.
Oh,
it doesn't always work for no reason.
No, it's not. I mean, it's not foolproof, right? Any of this stuff that we're doing. And certainly, like anything else, growing up, my dad was a mechanic. And so he taught me a lot about how to work on cars and stuff. And really, anymore, there's a lot of electronic stuff, and there's more and more electronic things. And I mean, as much as I love electronics, truth be told, those are more points of failure. Right, because we're adding more moving parts, and though technically they're not physically moving, right, they're just all these other systems and third-party components and things that we rely on to put together to build our software or to build, our piece of electronics or what have you, right? Like, not every sensor is going to be foolproof. Things fail over time, or something happens, and electrostatic shock or whatever, and inadvertently burn up components, or some other thing happens, right? So there's a lot of variables that come into play when you're busy not only building hardware, but also building software.
So how tightly are your classes coupled to the ones that Chris Gamble is teaching electronics with?
Well, right now, they're not very right. We're I guess they're kind of close, because at least we're going to use the same family of processor. But generally speaking, I would think they're not, because we're really trying to base everything off of this Nucleo board. Now, as time goes on, I think the videos will become more specific to the microcontroller boards and things. Well, at least initially, central command. There'll be stuff that'll be more, I guess, consistent with that, because there'll be like, well, how do we program this, right? We're going to be, we have a programming header we're going to put on the board, but we don't have the ST-Link device, right? So how can we leverage the ST-Link that comes with our Nucleo to be able to program an external microcontroller, right? For example. But I think as time goes on, we'll probably have some, they'll get more specific to the hardware we're building, but around sensors and, who knows what else. So.
How did you get roped into doing this?
Yeah. So, funny you ask. So, I have been listening to the Amp Hour for some time, as well as Embedded.fm. And because I love you guys. I love both shows. It's so mind expanding for sure. It's because there's a lot of things I'm still learning, even though I'm helping other people learn. But I had actually mentioned, there's a lot of times I had mentioned to my coworkers about listening to the Amp Hour. And my boss, Nick Berendt, he had said, "Oh, I know Chris," and so Nick is actually he's a adjunct professor at Case Western Reserve, which is Chris's alma mater. And he said, "Oh, well, I'll introduce you." And so I had a chance to talk to Chris briefly. It was a very nice sunny day. We were on top of the boat where I work, and he had mentioned that he was thinking about trying to put this component, this software component, and do this embedded courseware. And I said, "Oh yeah, I would totally be interested in that." And he said, "Oh, okay, that's awesome. I'm going to make an announcement on the Amp Hour, and we'll take it from there." So I made the announcement, and myself and Ron and an undetermined number of other folks basically competed, I guess, for lack of a better term.
Was there a gladiator pit? Because I just have this image in my mind that involves everybody at their keyboards, head to head, competing.
We're all in the octagon, Yeah, no, I mean, when I first heard about this, that's the same exact thought I was thinking. I'm like, wow, it's going to be like BattleBots or some weird thing, but only with software. Like, how are we going to do this? So, so we all submitted videos on how, presenting something. So Chris basically said, okay, I have an idea for doing, this Nucleo board or this Freescale board. both because they were very, very low cost processors and low quantity counts. And, go ahead and give me a video explaining how you would basically do an initial setup for that. And so we all submitted that. And one of the things I did was, hey, I also built this really cool thing using Vagrant and VirtualBox, and like this makes things so much easier, and I think it would be super helpful for the members and whatnot. And I'm like, and even if I don't get picked, like you're more than welcome, to use it and whatnot. And I can kind of give you a rundown of how this effectively works and everything, and so on. And so it I assume that helped, being one of the individuals picked to help lead the charge and do this. So,
do you totally want to go see what everybody else submitted and then recut it into a video where you're pretending that everybody's like fighting with giant axes or something?
Right. Well, it'd be some kind of weird thing. Yeah, like it would be great, but I think really you would need to have some sort of like, we have to really have a really good like sports announcer, so you can really kind of get the crowd, and the crowd being like what individuals watching YouTube, all wound up and everything, right? Like, oh man, this is going to be the best,
Eric goes for the Control Z in order to go quickly backwards, but now, oh my God, Ron pulls out the Control V and it's all done. Yay!
Have you seen Twitch?
Oh yes.
I mean, it's only a little bit different.
Right. Yeah. Oh my gosh. Yeah. I was thinking about that. The kind of thing. How would that be, right? And I've watched a couple people. I've actually watched some like live coding recordings of people doing stuff, boring. And I'm like, oh yeah, it's not.
No,
I mean, unless you have somebody running commentary and cracking jokes and stuff, it's.
Hey,
oh my God, he used a space instead of tabs, sir.
I know. What is he doing? What is wrong with him? Yeah,
where's that curly brace doing?
Compiler error. Yeah, it's no, it's not nearly as cool as it sounds in my head.
I don't think that'll take off.
So I don't think so either.
Sounds like fun to me.
Yeah. Well, now, so one of the things though, that folks might find interesting is that, Ron and I are planning on, and I don't think this will be every one of the upcoming videos, but as we go on, we're actually looking to do, pair programming and record that. So we'll be actually recording, some different aspects of what it is we're trying to solve or things we're trying to, functionality we're trying to build for, the central command board and doing the testing and things of that nature. So, although we haven't kind of finalized how it's going to look, but, he and I had been talking, and it's kind of like a, show camera views where it's like, here's the desktop and this is sort of what's going on. Or, if we need to do any kind of checks for, logic output or things like that, but also then have like our talking heads in the lower corner, which is right like Twitch, right? Twitch is usually like, and in my experience with Twitch has been Minecraft. So it's like watch way too much Minecraft on Twitch. But a lot of times, right, you have this individual, they're sitting there, they're testing their mod is a lot of times any of the stuff I've ever seen. But it's kind of like that. And so we're thinking like, having Ron and I. And so you get more of the, kind of like the team development aspect, right? So there's two of us, we're kind of talking through the problems and we're writing code. And then eventually that rolls into the, okay, now like let's do all the TDD stuff too, right? So let's, Unity or whatever we would end up using to test drive the code. And so since actually Ron has never done that, that's actually going to be a learning experience for him. So I think it'll be kind of great because we'll be getting, Ron's a great guy and we'll be getting some, I'm sure, great commentary from him on how all this works and sort of, live feedback from his experience of doing that as well as the pairing and whatnot. So we're trying to kind of introduce more like team development aspects, right? Because it's at least to me, when I write software and working where I work, we have our area is a completely open space, and we're not in cubes. We don't have individual offices. Everybody can hear everybody, and while that's if you're not used to that, it's a little unnerving until you get used to it. But it's sort of one of these things where like you end up learning a lot about the people that you're working with or the team that you're on. And you have a lot more collaboration and corroboration on how we're going to solve these problems or how we're going to get to the, next kind of milestone, whatever that is in the project.
Sorry, I spaced out there thinking about the horrors of an open office, but I don't think we should talk about that. I do understand talking more about pairs. Actually, let's talk about your day job for a little bit. What do you do at Lean Dog on the boat?
Yes. So I work for a company named Lean Dog. We do not make diet-friendly dog food. A lot of people call us
that. Yeah.
Oh, yes. And so we're on. So we mentioned earlier that we're on a boat. That is indeed true. As far as I know, still to this day, we are the only software company that is physically located on a boat that's in water. So we are moored, right? We're not mobile and like booking to Canada or anything like that. But
sort of sad, actually.
Yeah, we're completely
offshore for legal reasons.
Right. Yes, we are like Sealand or something, right? We are our own country. But so the boat itself is actually it's the front half of a steamship that was built in 1892, which makes it older than the Titanic. And the office is 2 stories tall, and we share it with another company, Ayers Keithley, their marketing firm. And it's really interesting because it used to be a restaurant, and it was kind of an icon of that area, the downtown, or I shouldn't say really downtown, it's the lakefront. So there's like Rock and Roll Hall of Fame, and there's this World War II submarine that we're parked next to. And then there's us, and we get a lot of, still to this day, being 2015, and the restaurant hasn't been open since I think 2008 or so, or maybe even earlier than that, that we get people coming in, hey, isn't this still a restaurant? And it really begs the question of, well, if you look around, it really looks nothing like a restaurant at all. But we're very big into agile practices, and that includes the whole open spaces and pairing and TDD and acceptance test driven development, or ETDD. So the area I'm at is what was the dining area effectively, and then what was the bar upstairs is an
okay.
area.
As fascinating as this is, I'm going to interrupt you.
Sure.
And suggest, what does Lean Dog do if they don't make diet-friendly dog food?
Yeah, right. So sorry, because I apologize because everybody's like, how are you on a boat? So we are a boutique software company. We do have a design and delivery studio. That's the portion that I'm a part of. And we build software for clients, whether you're a startup or you have an idea and maybe you don't have an IT staff, or you're a larger company and you need to do things like maybe Skunkworks. Or it's just, hey, you know what? I've got so much stuff going on and I have a ton of budget and my people can't actually get to it. Would you guys be willing to take this on and, build this internal product or product for sale, whatever the case may be, for us? We also have other portions of the business that go into training as well as agile coaching and organizational, I guess we call it organizational transformation. So that's, hey, you want to quote unquote go agile. What does that mean? And what does that mean for your business? And so we have folks that are on the road that will actually help the business and work with the actual business side and kind of get them going. And then folks that will be embedded with the development teams and actually teach them things like pair programming, user stories, TDD, ATDD, and all the other awesome acronyms that come with working in Agile. So,
but which do you do? What is your function there?
I am primarily a developer for them. So web primarily, as well as I do a lot of the DevOps for our customers if they do or do not have infrastructure and they need help with that. So I've set up a lot of environments, done a lot of load testing and things like that for our customers. Obviously embedded, worked on a couple different projects, doing varying levels and prototypes and whatnot. and also have done coaching in the past, I've been actually on premises and taught people TDD and so on. And outside of that being my kind of day-to-day thing, I a lot of times will give talks at colleges or high schools to students about either kind of, being in the software development field, or even just other topics like, if a high school class is interested in learning about like 3D printing or building something basic with Arduino and things like that. That's all kind of things I do from time to time.
So on your resume or LinkedIn or however I cyber stalked you, it looked like right. You do a lot of different things. Ruby, Rails, Python, iOS, embedded. There's a lot of breadth there, and there's a lot of commonality between languages, but
sure.
Sometimes embedded in particular, because that's what I know, depth is required. How do you balance?
Having a really good memory? No. That's a huge help for sure. It's hard. I don't know. I guess for me, I always kind of look at it. It's hard to remember everything. And certainly, I think the hardware, to a degree, forces you, depending upon what it is, right? So I kind of view it as if you're in a Cortex family, there's probably a lot that's fairly applicable across the board, whether you're using like an M0 or the brand new M7s that just came out. If you're kind of looking at, just general functionality, but I'm very good at, or have gotten very good at, being able to kind of look things up and, reviewing data sheets or, digging through the language and trying to remember, how do I do this particular construct? Or if it's, maybe not so much C, but things like Python or some of the other interpreted languages, or even really Java and C#, there's probably some kind of a module or a plugin or something that does these sort of things, so I don't necessarily have to reinvent the wheel. Let's kind of figure out what that is and incorporate it. So it's when years ago I had been doing .NET for almost 10 years, and when I first started doing .NET, after I got the general gist of what was going on, most of the framework I could pretty much remember and be able to kind of use like something as simple as a text editor and then just build it. I didn't necessarily have to use Visual Studio and all the IntelliSense stuff that came with that. But it's now there's no way. Just the base .NET framework itself is so massive. There's no way that you're going to be really able, at least I don't think that you'll really be able to remember everything and be effective in that way. So there's a lot of like having the cursory knowledge of how the things work and where to look when you're trying to kind of jog your memory, right? So that could be a data sheet or really anything else, I think.
So how do you define the difference between software and embedded software, or software and firmware?
Wow. Well, I suppose I kind of look at it as embedded is not Linux. So I don't know. I don't necessarily, I guess, consider like a Raspberry Pi or a BeagleBone or something like that to be necessarily embedded. I always look at embedded as it's bare metal, like the software that's running on bare metal, right? So that's embedded. And then everything else is just kind of application software. Right. So even if I'm doing something on a Pi that is, for convenience sake, say written in Python, because there's all these, Adafruit has all these libraries to deal with the GPIO pins and whatnot on a Pi, makes it a lot easier to do that. You're still, maybe running or writing services that run on the Pi, but they're all contained within Linux, right? They're not necessarily bare metal, like what we're, trying to do with whether it's an Arduino or these Nucleo boards or any other microcontroller.
How do you describe the difference between techniques in application software, web development, and the techniques that you would teach in contextual electronics for embedded developers? Are there different approaches, different tactics, strategies, thoughts?
I think a little bit, right? So, I mean, one of the basic things, right, is that if we're using C, we don't necessarily have classes, right? So it's more procedural, I guess, because you're going to have just this like global space of nothing but functions, right? So the kind of grouping things together will be really sort of relying on things like header files, and that's going to be probably about as good as you're going to get until you move to something like, say, C++, where you actually have classes and whatnot that help you at least build, I guess, a little bit more of a structure that you might be used to if you already have experience in object-oriented languages, right? So there's some of that is a little bit, I think from that aspect, it's a little bit different. I mean, some of the things like building it certainly are different. So you can either, right now we're really relying on Eclipse to kind of put the projects together and generate the makefile and sort of do all that stuff behind the scenes. But, if you're doing some other piece of language, say if you're doing C#, you're potentially, most likely, you're probably doing Visual Studio. That's going to set up all these MS build files for you and one main solution and kind of orchestrate it for you, even if you're compiling it from the command line, right? You're going to feed something in an MS build, and it's pretty much going to wire it all up for you. Versus something, say, like Python or Ruby, right? You're just going to run an interpreter, and as long as you required all of the files correctly and you required your libraries or imported them, if you're doing Python, it's going to, take care of all the compilation and the execution of that. So there's different, like the different structure, I think, is part of that is getting used to for students if they've had a software background. But a lot of that is just kind of how we decompose. I think other things will be like how we decompose the problem and deal with, if we're dealing with hardware, we're dealing with registers and other things that you just don't have in application software. You're going to have, probably like a serial port class or something that helps you communicate, depending upon if you're using some vendor piece of hardware, like maybe some sort of USB library that's a driver library for a particular piece of dedicated hardware, right? That comes from a niche manufacturer. You're going to have those drivers and their SDK, and you can, if you look to do things like TDD and stuff like that, you're going to look at how can I mock these things out so that I can focus on tests for isolating, my code and not deal with those hardware. Well, when you're looking at specific hardware and doing firmware, now it's like, I'm going to isolate hardware, but I'm going to do it at this much, much smaller level where I'm going to be, isolating registers or serial buses or, other things that kind of come into play. So I think it's the same general ideas, but I think a different level of granularity is probably where that becomes different.
Well, one thing that comes to mind also is if you're coming from a general application background, you don't usually think too much about resources, right? And if you're developing on a Cortex M0, suddenly you might have these people who are like, well, what do you mean I can't just have whatever memory I want?
No, yeah, you can't. You cannot do the kitchen sink, right? That's not an option, right? Neither is failure. No, just kidding. But the whole thing is that, yeah, you really have to kind of focus on what it is you're trying to accomplish, and at minimum, really write the minimum amount of code to make it work. And as far as libraries and things are concerned, use what is the minimum amount that you need to make things functional, right? You can't, because of the limitations, you cannot just, hey, let's just pull in like all of this, peripherals library and do all this stuff. A good example of this is that if, listeners have been messed around with like an Arduino and Adafruit has a breakout board for the TI CC3000 Wi-Fi chip, there's actually their library, their C library, when you go to its GitHub's page, actually mentions to say, hey, if you're using this on a certain class or higher processor, you can actually use all the functionality that the driver will give you. And if you're on, I think, I can't remember if it's a Teensy or something, maybe it's an AT Tiny. It's a particular level of Arduinos that if you want to use that CC3000, so you get some level of network connectivity to like maybe push logging or ping a URL or whatever, you have a much finer subset available to you because of the memory constraint for that processor, right? So that's depending upon what you're doing, that may actually come into play in writing drivers if you have to support different levels of, say, different kinds of products. And maybe one product has an M0 and another one has a Cortex M4 that's got like a half a mega RAM versus the 32 or 62K of RAM on an M0, right? So that certainly would be an example of something like that where you're much more resource constrained, certainly. And you have to take that into account, right? It's not like, hey, I'm running a MacBook Pro at 16 gigs of RAM, and sure, I'll write a Python script and like load all the things into memory and, go from there. That's not so okay on a microcontroller.
So talking about libraries and cross compatibility with different controllers, you did a video on CMSIS. Could you tell me about it?
Sure. So CMSIS, for folks that don't know, because we, being right in electronics and software, we never have enough acronyms, right? Is the Cortex microcontroller software, or oh my gosh, here I go. So it's a serial, basically their specification, interface specification, right? So that gives us, it's a nice thing that ARM actually did. So for the Cortex series of processors, it gives us a baseline way to access things like registers and deal with, even though the processors come from different vendors, right, from TI or ST or Freescale or NXP, you can, if they're all stamped with the CMSIS specification, you can be sure that at the bare minimum in the libraries that you can actually access all of the registers in the same manner and program whether it's I2C or any of the other buses, right, CAN and all these with the same, doing that all in the same way, right? But still allowing the manufacturers to kind of differentiate as far as, what do they bolt onto the processor, right? So it gives you a baseline that makes it easier to deal with moving code amongst processors or even potentially amongst manufacturers. So
so it's a hardware abstraction layer,
right?
And it allows different implementers based on who is making the chip. So you're not dealing with the same code across different platforms. It has some interesting effects because of that. Like if you read the CMSIS code, you may find out that there are a lot of side effects happening that you didn't necessarily expect, especially if you're used to doing things with registers or even application code. You might not expect, I'm not only setting this GPIO, I'm clearing all of the other ones and then resetting them, which might have interesting effects.
Right. So interestingly enough there, oh my gosh, now I'm trying to think. I know recently that there was mention about there is an edX course on microcontroller development using the Tiva Launchpad, which is a Cortex M4, and that's given by UT Austin. And actually took that earlier last year just to get a really good idea, kind of on how do professors teach a class like this? I've never taken any class on edX, so I thought it'd be a good opportunity to kind of check all this out in one shot. And the professors made a really good point about kind of like making like friendly changes to registers, right? Do things like bit masking and going in and saying, okay, great. What I really want is like, given the data sheet and what's going on and what registers correspond to what ports, and those then, each bit in the byte will tell you, say, okay, each bit represents a pin and so on, right? So you want to use like masking or or use flags in actually trying to be mindful of what you are setting or what you are overriding, so that you get the pin that you want, and you don't do exactly what you just said, which is like, oh, I'm just going to like equals this thing out, and I'll set it to this hex value, and it sets this pin, and then it's not until later when you're maybe trying to do something with other pins in that port that you then realize, like, whoops, I actually like wiped out all these other pins, and I ended up like I disabled them, or I turned on their alternative functionality, which is not something I meant to do, or things of that nature, right? So it's that certainly there, with great knowledge comes great responsibility and all that. So, or great power comes great responsibility. So it's definitely, you have to kind of be mindful of what you're doing when you're working at that register level.
And the CMSIS is very helpful as example code and very helpful as prototyping code. But if you want to use it for everything, consider rewriting part of it, because it's not necessarily efficient. The goal is to check this box off for ARM implementation. Only a few processor vendors are taking it seriously as the goal is to do something awesome here.
Right.
And I haven't met any of those processor vendors, so don't ask me which ones they are. I'm just sure they're out there.
Sure.
I can mention some ones that don't take it seriously, but that's sort of rude.
Sure.
So you talked about watching edX videos to get sort of prepped for teaching this way. What else do you do to prepare a lesson? I mean, how do you decide how big you're going to make it, what you're going to talk about, and how you're going to present it?
Oh, yeah. So I think sometimes I kind of feel like sometimes that's a little like, that's sort of all over the place. I guess it depends on what the topic is. So a lot of times, if we're looking at things where, it's, I don't mind talking to people, especially if it's a thing I'm really interested in. But certainly for things like videos, you gotta try to keep it as short as you can, I guess. So, you don't end up losing the audience. And so it's kind of, depending upon what the topic, a lot of things I try to think about are what's the shortest potential example I can come up with to try to get a particular point across. Or if it's something like, say like the I2C or SPI intros, it's like, all right, well, what we're going to do is we're going to do something very simple. We're going to configure that piece of functionality and then at least validate that it functions using a logic probe. And we're not going to go anything further than that. So it's let's come up with a contrived example, I guess you could say, of just getting to that initial point, right? What's that like really short kind of win that we can have to sort of illustrate a point of, in the case of the intros to those buses, just get something working and validate that we say, oh yeah, no, I can see that we're pumping data, and I can see that, the information we're pushing on the bus, like, oh yeah, here, the logic software is showing us, like, here's the actual bits that we're sending, right? And we can see that and correlate it to the code we wrote, and at least understand that, we do have things configured properly. For example, a lot of things are like with the C fundamental stuff is just sort of a little bit more difficult, because some things it's how do we kind of illustrate some of these things if you either don't have a background in C, or potentially you don't have a background at all in programming. For all I know, we could be having members coming on that don't have a program background at all, but they have enough interest that they want to try to learn this. So it's hard to get that balance.
Yes, exactly. I mean, that's always the balance with trying to teach something, is you need to know who your audience is so that you can connect it with what they already know. So how would you change prepping for contextual electronics versus prepping for a real life class or an hour-long seminar at a conference?
Well, probably not. I guess overall, probably not too much different, but depending upon what the subject would be, it's a lot of times if I'm trying to teach some sort of a class on something or give a talk, I do like to have a number of examples, depending upon how much time I have. But I think it's helpful to have in context examples of what the subject is we're talking about. So recently gave a talk to the Case Western Reserve Hacker Society, and it was around. I did some prototyping work with a TI sensor tag. Have you guys ever seen those or messed with one of those?
Yeah, they come in two flavors now. They're BLE with the sensor on them, and you can update the code if you really try. But for the most part, it's learning to write the application that works with the tag. Right.
Yeah, the mobile app, right, in this case. So I had done a prototype where I needed to add just a little bit of functionality to the firmware. And so I thought, well, that, kind of not so much a lessons learned, but like, here's some things that we were doing to deal with, I want to write firmware. How do I go about that? And what does that look like? And so there were some examples. I gave a little bit of code examples of like, oh, here's things that I changed to say hold a value, right? So I want to be able to double tap, I guess, the user button on the sensor tag, and I wanted to basically take a snapshot of the readings and stream the snapshotted version over BTLE, as opposed to the constant updating every second, which is the default behavior of the firmware. And so there was like, show a little bit about that. Okay, now we have a example application, a custom app that pulls that values in and shows that in our iOS app. And then later, I basically showed an example of like, oh, here is using mobile Safari, and that the app native app I wrote also happens to be an application extension, and I can actually plug values from like temperature or barometric pressure into Google and ask Google to do temperature conversion for me, right? Just to kind of give the students sort of an idea of like, there's this thing, and here's how we like modify it and leverage kind of what comes out of it, and give some, actual like physical example of that, as well as like code and things like that you potentially would if it was a session, around development with an SDK, for example.
So what about Arduino? You do have a few videos about that on CE, right?
Mm-hmm. Yes.
Do you use it a lot? Do you like to teach with it?
I do a lot of times. I mean, outside of contextual electronics, I have a lot, and just kind of if I try to from time to time participate in a local a group that we have host at Leandog called Make on the Lake. And there's been a lot of times we try to do kind of like simple projects that have sort of get people interested in things that, if you can you do it like in an hour and a half or 2 hours projects. And a lot of times those will be with things like an Arduino or Particle. And I think that's an easy way an easy point of entry, right? So certainly there's a huge ecosystem with breakout boards and expansion and all kinds of stuff around Arduino, as well as custom Arduino stuff. But the IDE, right, the Arduino IDE certainly takes care of a lot of the details, and the details being things like all the register configuration, right, for making a pin do a digital read or a digital write, or analog read or write, or turning on I2C, or a lot of those kinds of things, where they take that needing to know the detail behind how that works in the processor, whether it's an AVR or it's the newer the Zero or the Dway, where they're actually ARM based. You don't have to worry about that, right? So I think from a beginner standpoint, that is an easy way to kind of get started and sort of get the small wins kind of thing with, hey, I can actually like light up this LED by activating this pin if I'm using an Arduino, and then sort of like build on it from there, right? I think there's definitely value in that. That is a starting point, and we have like one of the videos we have is kind of migrating away from the Arduino, right? And there, because there's a lot of like quote magic that it does with the code that it compiles, you now move into, okay, great. Now, if we're going past the Arduino and you're going to like a Nucleo or one of the Freescale Kinetis Freedom boards or something like that, well, now you're getting into now you actually have to learn like the deeper functionality of how do you make the pins work the way they do, or how do you, manage the program as far as, if I want to do any kind of logging, for example, and I want to use like a little portion of memory and try to, store some information there temporarily before I, push it over Zigbee or something like that, right? So there's all these different details and things that I think are, and rightfully so. I don't know that if you're just kind of looking to tool around with it, right? An artist that wants to make some kind of display and light it and learn a little bit about how to do that, he can certainly use an Arduino and not like, he doesn't need to know, right, the ins and outs of that. But if we're, kind of a lot of other folks that I've met that kind of have used an Arduino and are very familiar with it are like, okay, now I want to do more with it. Maybe I want more I/O, or I want to do these other things. And I'm kind of like, outgrown it, I guess, for lack of a better term. Now I'm going to, move on to something else. So sometimes that's Raspberry Pi, and sometimes, or BeagleBone, or any of the single board computers, or that might be, higher order microcontroller, like some of these Nucleos and things like that are more powerful than your, Atmega 328 or something like that.
Just about anything is more powerful than your
pretty much. Pretty much.
So with teaching like contextual electronics and the apprenticeship idea, is college no longer useful? Actually, did you go to a 4-year university?
Oh, yes. So that's no. I did. I did 3 semesters and quit. I never went back. So technically I'm still a freshman, according to the state of Ohio. And a lot of what I've been doing has either been teaching myself, so that includes even software development, or basically pairing with people and learning from others. So whether that learning from others is I'm actually physically sitting next to people and kind of being mentored, or videos or classes, whether it's physically showing up to a class or doing stuff online, like contextual electronics or edX. I've been kind of wherever I can learn something new. So, and even reading books and doing, trying to recreate the programs that I see in the books. So, a lot of those sorts of things, those are just any of the different avenues I try to leverage on learning. So, yeah, I don't know. I think that's a tough question. I think there's a lot of, depends on what you're doing, right? I mean, you can learn a lot of what electrical engineering does, for example, from, say, something like contextual electronics. But I don't think, say, you took something like civil engineering, I don't know that that's possible. Like, I don't think you could be a civil engineer and not go to an accredited college and get a degree in it. So I think some of the stuff, I generally think it sort of depends, right? So software, I mean, there's a ton of software people. I know lots of people that have CS degrees. I know people that are great programmers that have degrees in music. And I know lots of other people that are great developers that don't have degrees at all and are self-taught. So that's kind of a tough thing. So I think it's just depends on what you're going after and to the level, right? So like if you're just learning to cursory knowledge of software, you could probably take classes, but I don't think you would necessarily need to have a degree involved to have some level of proficiency.
Yeah, being able to program is not that hard. Being a software engineer, I think, usually takes more than that.
Right. Yeah, it's there's a great analogy. I was hosting an open space at the Codemaster conference I just attended, and gentleman Guy Royce made a great comment where it's kind of like, depending on your level of learning electronics, we're all software programmers, and if you take a look at things like using an Arduino in breakout boards versus trying to, go and actually like build analog electronics and design your board and build firmware. It's sort of the difference between those two dichotomies is like script kiddies versus actual programmers, right? Like if you're just kind of learning, you're just going to sort of cobble things together and you can get it mostly to work versus I actually know why this works, right? And that's that huge difference between them. Really, a lot of times is going to come with what you learn and then experience, like, because, nothing can really replace actual experience. You can read about it all you want, but unless you actually try to do it, it doesn't reinforce it. So,
well, I think that's actually a pretty good point to end on. Eric, any last thoughts you'd like to leave us with?
Sure. Yeah, I really think that no matter if you're trying to do electronics or you're trying to do software, even embedded software or application software, really, I think the important part is don't be afraid, right, to just get in and get your feet wet and try to learn stuff. Don't be afraid to make mistakes. And certainly in this day and age of, relatively speaking, how cheap electronics are. If you're looking to just kind of tool around with things like Arduino or any of the breakout boards, like don't be afraid to accidentally burn it up, right? It's relatively speaking pretty inexpensive. So there's, I think, a lot of learning opportunity there and available to folks out there that they want to get into electronics or software development. So never stop learning. Don't be afraid to make mistakes.
Seems like good advice. A little bit of destruction goes a long way towards education.
It does. It does.
Our guest has been Eric Hankinson, instructor at Contextual Electronics and Ruby iOS, DevOps developer, and Agile coach for LeanDog. Note that Eric brings us a coupon for getting 10% off of Contextual Electronics. Use embedded.fm as you check out, and it is good through June 2016. Note that it's, if you go for the participation level, you get, $6 off every month until from now to June. So maybe time to start that resolution.
Yeah, totally worth it.
Thank you for being here, Eric.
Thank you.
And thank you, listeners, for listening and for my new iTunes review, which was 5 stars, which are the best. Also, thank you to Christopher for telling me about it, for producing, and for co-hosting. He does a lot. Hit the contact link on Embedded FM if you'd like to say hello, or email us, show@embedded.fm. We'll be here next week. I'm not quite sure what we're going to talk about. There's a little note in here. Tease future show. And I don't know what I was thinking when I wrote that. I never do that. In the meantime, whatever the next show is, a final thought to leave you with. This one is from Michelle Silverstein, from Where the Sidewalk Ends. There's a little poem called Homemade Boat. This boat that we just built is just fine. And don't try to tell us it's not. The sides and the back are divine. It's the bottom, I guess, we forgot. Embedded FM is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive any revenue from them. At this time, our sole sponsor remains Logical Elegance.